Hi guys, welcome back. Hope you understood lesson 10.2 on improper integrals okay yesterday. Thank you very much for working so hard. Okay, so today is going to be partial fractions, and to give you an idea what that means, we're going to start with bell work that leads into today's lesson. So, and if you want to stop and pause and solve this on your own, you can. But I know you guys know how to do this, so I'm just going to do it real quick. Okay, if I said simplify and you're adding, then you would know, hopefully, you need a common denominator. So we've done this many times. Multiply this guy by that guy. And of course, whatever you do to the bottom, do the same thing to the top. Multiply this guy by that guy, x minus 3. Do the same thing to the top. And now you have the common denominator that you need. Keep your common denominator, x plus 1, x minus 3. And it's just like if I said, what is 1/3 plus another third? You keep the common denominator, you don't do anything with that, and you add the numerators. No, sorry if it looks like I'm treating you like you're dumb, but it's more abstract with the algebra. Say hello to my dog. If you guys can see, my dog has joined the lesson. Look out here. Okay, so we have the common denominator, and now just distribute. You get 3x plus 3. Be careful with that sign. That's a plus. This is a positive 2. 2x minus 6. And just combine like terms, and you would get 5x minus 3 over x plus 1, x minus 3. And that's it. Okay, so that's the order that we're used to doing things. Today, however, we're going to take this, the answer, and you're going to be asked to integrate it. Okay? Well, let me FOIL this out so you can see what that would look like first of all. So we have 5x minus 3 over, this would be an x squared minus 2x minus 3. This here is the question that they would ask you to now integrate. Well, if you notice, you first try u sub. The derivative of the bottom would be, what? You tell me, what would the derivative of the bottom be? Hopefully you said 2x minus 2, and this is not a 2x minus 2. So that's your clue that there's some other thing you have to do. So here's the trick. You take this fraction and we work it backwards so that it looks like our original question. And then you can integrate this and this separately. Okay? So that's our goal. We're going to take this fraction and change it to partial fractions, and then we can integrate each term separately. All right, so I'm going to take this answer right here and we're going to work it in reverse. Okay, notice that this question is exactly the same as the last answer. Okay, our goal is to integrate this. So first, kind of ignore the integral. We're going to break it up using partial fractions. Factor the denominator, x minus 3, x plus 1. And you kind of just have to know when you have two factors, and these are called non-repeating linear factors, meaning it's an x to the first and they're not the same. If they were an x squared, or if you had two of the same factors, you wouldn't do this method the same way, but this is all that's required on the AP exam. So first you just got to know that it's going to turn into one fraction has an x minus 3 and another one has an x plus 1. Okay, and now our job is to figure out what goes here in the two numerators. Okay, we got to figure out what is a and what is b. And after we figure that out, integrating this would be the same as integrating this. So that's my goal. All right, well, it's a little bit of trickery. It's super cool. What you're going to do is write it as an equation like I did, okay? Multiply the entire equation. Pretend that integral wasn't there. I didn't mean for that to still be there. Here, let me switch. Just trying to make a point. Okay, back to the same exact thing right here. Okay, we're going to take this equation and I'm going to multiply the entire equation by the common denominator. So I'm going to multiply each and every single term, and you'll see a shortcut real quick. I'm going to multiply everything by x minus 3, x plus 1. X minus 3, x plus 1. X minus 3, x plus 1. Okay, and again, you will see a shortcut real fast. So now cancel. The x minus 3s we have in common, the x plus 1s we have in common. So this term turns into just 5x minus 3. Here, on this term, the x minus 3's cancel. Now I got a times x plus 1. And don't distribute the a. You'll see in a minute. Plus, here the x plus 1's cancel, and you get b times x minus 3. Okay? Now remember, our goal is to solve and figure out what is A and what is B. Back to this where I wrote it. I want to know what goes here and what goes here so that I can then integrate each individual term. All right? So, a little bit of math trickery. First, before I get to the trickery, can you see how you could come up with this line without really showing all the work that I just did? You can kind of multiply by the common denominator in your head. All right, try to remember your goal. We're solving for A and B. Well, here's how you do it. Let either x equal -1 so that this turns into 0 and goes away, or let x equal 3 so that this turns into 0 and this term goes away. You're actually going to do both of those things. You're going to take turns. So I'm going to let x equal -1. Watch what happens. Let x equal -1, and that means all of the x's in the equation have to be -1. So I'm going to plug in a -1 here, here, and here. So if this is -1, 5 times -1, -5, subtract 3, and that's going to turn into a -8. When I let this equal -1, -1 plus 1 is 0, so that term goes away. 0 times a is 0, that goes away. Let x equal -1 here, and I get -1 minus 3, which is -4b. -4b. Now look how easy it is to solve for b. Okay, divide by -4 on both sides, and b equals 2. That is going to go way up here in our original question. You're going to plug it in where the b was. We now know that this is 2. Okay, so we now know over here that this b right here is actually a 2. Now I got to figure out what a is. So we basically do the exact same thing. Okay, this time let x equal 3. X equals 3. And you have to let all of the x's in the entire equation equal 3. Okay, so if x is 3, then 5 times 3, that would be 15. Minus 3 would be 12. Equals, let this x equal 3. 3 plus 1 is 4a. And if x is 3 here, 3 minus 3 is 0. That term goes away. Solve real quick. Divide by 4 on both sides, and a is 3. So that means that way over here, this fraction, that a is actually a 3. Okay, so now I'm going to take you back to that last page where we started. That means that the a here is actually a 3. Now, if you compare to the bell work that I gave you, that's exactly the same as the question I gave you for bell work. If you can see here in black. Okay, I don't know if you can see that. Yep, you can see that. Okay, so now you have the same exact question that we started with. Okay, so now refer to the goal. The goal is not to figure out what the partial fraction format is. The goal is actually to integrate this question. Okay, but to integrate that question, I've now made it easier. I can now, instead of integrating this, I'm going to integrate its equivalent, which means I'm going to integrate both of these. Okay, so now integrate. Take a minute and think to yourselves, the integral of 3 over x minus 3. Hopefully you figured out that that's a natural log. So it's 3 natural log of x minus 3 divided by the derivative of the inside, which is 1, so that's easy, plus 2 natural log of x plus 1 divided by the derivative of the inside, okay, plus c. That's it. We're done. Very, very easy to integrate it. The time is spent doing all the algebra to separate it using partial fractions. Okay? Hopefully you're good. Now's a good time to pause if you want to, if you need to. Pause and ask each other questions. But I'm going to do another example, so hopefully you'll be good by the next one. So pause now. Okay, number 2. I really don't think this one is any different than the last one. So if you'd like, you guys can pause the video and just solve it on your own. So pause for a long time and just see if it's stuck, because the next example that I do is going to be totally different and probably going to blow your mind. So you might want to just do number 2 on your own right now. Okay, so hit pause for a while, give everybody time to try to integrate this problem. Okay, so hopefully you're back. I hope you guys did well. Let's see. Okay, ignore the integral at first. Write an equation. X minus 6 over x. What will this factor into? X plus 3, x minus 1. Hopefully I did that right. Yep, that looks good. Equals, I know I'm going to have an x plus 3 for one factor, and I know I'm going to have an x minus 1 for the other one. Okay? Then I say this guy's A, this guy's B, and my goal is to figure out what is A and what is B. Okay? Multiply everything by the common denominator and cancel. You should really be able to do that in your head so you don't have to show so much work. I'm going to multiply by x plus 3, x minus 1. X plus 3, x minus 1, x plus 3, x minus 1. So here everything cancels, and I get x minus 6. Bring down the equal sign. Here the x plus 3's cancel, I get a times x minus 1. And here the x minus 1's cancel, so I have b times x plus 3. Okay? Do your little math trickery. Let x equal let x equal 1 to make this go to 0. And let x equal negative 3 to make this go to 0. Okay? So when x is 1, I get 1 minus 6. I have negative 5 equals that 0. This is 1, that's 4b. Okay? Solve, and you get a fraction. So b equals negative 5/4. You might not have known what to do with that up here. I'll show you in a minute, okay? Now let x equal negative 3. If this is negative 3, this guy goes away. That's 0. Negative 3 minus 6, that would be negative 9 equals. If this is negative 3, I get negative 4a. Solve for a, divide by negative 4, and a is 9/4. Okay, when you go to plug that in, I'm going to plug that in here. I may need to use another sheet of paper. I don't know if I'm quite going to have enough room. Okay, I'm going to rewrite that. I have a over x plus 3 plus b over x minus 1. Okay, and we found that a was 9/4. And b was negative 5/4. Okay? Is everybody with me for now? Right. Plug that a in on top of the numerator and oddly leave it as a fraction. So plug in the 9/4 right here and leave it like that. It's 9/4 over x plus 3. It's just easier to integrate, you're going to see in a minute. Plus, the b is negative 5/4 over x minus 1. Okay, now remember the goal. The goal was not to separate the fractions. The real goal, look back at the question, the real goal is to integrate that. So don't forget, what you need to do now is actually integrate term by term. And that's why it's easier to leave the fraction here, because this will just be 9/4, the natural log of x plus 3, plus, make that minus 5/4, the natural log of x minus 1, plus c. Okay? Pause, catch up, ask questions. The next one's going to be very, very different. So notice that the two examples I did, the degree on the bottom was one more than the degree on the top. You're going to see the next problem is very, very, very different. So make sure you ask all the questions you have. Pause for a minute, because the next one's going to kind of be tough. Okay, first, the last one. I really don't see this one very often. Really, don't stress too much over this, okay? I'm just showing it to you just in case, but I really, really, really don't actually think you need to know this, okay? But just in case, and it's kind of cool. All right, this one, notice the degree on the top is more than the degree on the bottom. Anytime that happens, you have to use long division, like third grade math. You have to divide this guy divided by this guy using long division. So let me show you what that looks like. Put the numerator underneath that little bar thing. I don't even know what that's called. Okay, ignore this 2x right here. And put the denominator out here. We're now going to divide. To do that, you look only at the first terms and think to yourselves, don't yell it out, x squared times what will give me a 2x cubed? Okay, now yell it out. X squared times what is 2x cubed? And hopefully you came up with 2x. Now take that 2x and multiply it back out to all three of these guys. 2x times x squared would be 2x cubed. So that goes there. Then 2x times 2x, that's going to be a negative 4x squared right there. And 2x times a negative 3 is a negative 6x right there. And now, just like in third grade math, you would subtract or add the opposite. Change the signs. and add, and you get left over 5x minus 3. Well, what does this mean? If I said old school math, if I said I had, let's do like 12 divided by 5. 5 divides into 12 2 times. Multiply, subtract, same steps, and I'm left with 2 left over. Well, how can I write this answer? This is the main answer. It's 2 and 2/5. And that and actually implies a plus. We could say 2 plus 2/5. Okay? We're going to do the same thing with this. We're going to rewrite our answer as my answer, 2x, and this guy divided by that guy, 5x minus 3 over this. Okay? Now, what was the point of that? What they would then do, the question isn't going to be just divide. That's actually an Algebra 2 question. For you guys, it would be integrate that. Well, that means if I rewrite the answer this way, I'm going to integrate this and this. Okay? So, that's a hard problem. This guy is easy to integrate. This guy, guess what? Partial fractions. It's exactly the same as the first problem I did with you. Okay? So that is where this answer would come from. Okay? Actually, this is just not integrated. We would then integrate this. Okay? Which I'm not going to do because we already did it in problem 1, but you would integrate this and this. All right, that was a doozy. I don't think you really are going to have to do this, but just in case, pause for a minute, look it over. This usually kills people because you don't really do long division much. And I really, like I said, don't think you have to know it. I won't test you on it, but just in case, I'll give you a couple in your homework. All right, so here's your homework. Okay, again, this is partial fractions, and it's the opposite of getting a common denominator. Okay, so good luck. Hope that went well. I'll see you for the next one. Bye.